Hello there, developers, and welcome to this day 3 of the ROS2 Learning Week, where we are going to start learning some basic concepts of ROS2. So, let's go for it. Alright, so welcome everybody to this day 3 of the ROS2 Learning Week. As I have just said, today we are going to start with ROS2, so we are going to start with the basic concepts from the beginning. So don't worry if you don't have any background on ROS2, if you are a completely newbie on ROS2, don't worry because we are going to start from the very beginning and from scratch. So from the basic concepts like how to create a package, how to create, we are going to create our first ROS2 program, very basic, some important subjects like what are nodes, launch files, etc. So all this is going to happen today, and what I'm going to do right now is to not lose any more time, and I'm going to switch right now to my computer screen. So let's go for it. And let me refresh here my screen. So as always, we are going to be here in the main ROS2 Learning Week panel. So remember, again, to everybody, I want to remember that you can fine-tune the volume here if you want to hear it louder or lower, whatever you prefer. I'm going to be reading you here in the chat. And these two first days, on day 1 and day 2, we have been working on a course, so that we had to open another tab, a different tab, where basically we were working on the course, and then we had in another tab this main panel of the ROS2 Learning Week, right? So today we are going to change this procedure and the setup, and we are going to be working on a project, all right? So very easy. What we are going to do right now is to scroll down this screen, the basic ROS2 Learning Week page. We are going to scroll down. We are going to find here the agenda, a brief summary of the agenda. And then down here, we are going to find two more elements. One is the conference documentation, and the other one is the related courses, all right? So let's have a look at the conference documentation, and as you can see here, we have a project placed here, all right? So this is the project that we are going to be using for today's class, this ROS2 Learning Week Day 3 basic concepts. So what you need to do in order to get and open this project? Well, super easy. You just need to click on this button here, fork and open project, all right? So let me repeat it. In the main page of the ROS2 Learning Week conference, just scroll down here, and in the conference documentation, you're going to find the project for today's class, and you only have to click on this button, fork and open project. All right, I'm going to do it right now, and this is going to automatically copy the project to your workspace and open it, as you can see right now. All right. Furthermore, you are going to now have in this page, in the project page, you are going to be able to see the streaming and visualize the chat as well, right? So if you click in this button here, show video and live chat, which I'm going to do right now, this is going to open the chat, all right? So no need to have any more two different tabs. We are going to work on this one. So super important, let me repeat it one more time. In the main page of the ROS2 Learning Week conference, scroll down here to the bottom of the page, and you are going to find the conference documentation. And in the conference documentation, in case you have it like this, minimize it, just click on it and it's going to open. And then here you have to click on the fork and open project, all right? And this is going to automatically fork and open the project, which is going to take you to a page like this one, okay? So now in the project page, as you can see, you are going to be able to have the streaming opened here. You can open it in a different tab if you prefer it, whatever you like the most. But you are going to be able to have everything in this project page, both the streaming and the chat. All right, so hello everyone. Hello from Brazil, from Barcelona. Hello, hello. Hello everybody. I missed it. What did you miss, Krishna? Hello everyone. Yeah, so here in the main page of the conference, in the main page of the basic ROS2 Learning Week, you just have to scroll down here until you find the conference documentation and then click on the fork and open project. Super easy. So no possibility to get lost here. All right. I can fork the project. It's giving an error on a space. Okay. So you are getting no more storage space left. You are getting, all of you are getting this error. Or it is loading for you, the project. The time to load, it's so long. Well, it might take up to a couple of minutes, something like that, which it's normal because there is many people right now opening projects and making requests, so it might take a little bit more than usual. So can you confirm here in the chat that you are getting this no more storage space left? Who is getting this error? No more storage is okay. Okay, so K4K is getting this error. Same error, Roberto, also Baromero. Okay. Okay, so don't worry, my colleagues are already looking into this to see why you are getting this error. Has somebody been able to load their project like I have here? Does somebody have the environment loaded here with the notebook opened and the page still loading? Yes, Mailen. Loaded, okay for me. I have loaded. Okay. Okay, so it looks like this is only happening to some people. So don't worry. We are same issue. No more storage space. Okay, don't worry. We are already looking into this, and it's going to be solved right now. So don't worry. I'm not going to advance. I'm going to wait some minutes until everybody can have his project and launch it without issues. Still loading, need 4 more minutes, load is fine. Already loaded, okay. So for some people it's taking a bit longer than usual to load. Let's just try to be patient. Yeah, if you have more than 2 gigabytes of ROSjects, you have to delete some. Is saying here, Baromero. Yeah, that's true. However, that is true. So there is a limit for free users of 2 gigabytes. However, for these special events like this conference, this doesn't have to affect. All right. So even if you have already reached or surpassed the limit, you should be able to get this project. Yeah, in the same way as live classes work. So even though you already reached the project limit, the storage limit, you can still get the projects of live classes, for instance. So this is the same. So our idea is that even though you have reached the limit, you are going to be able to get this project because it's something that we are providing for free. It's just it's a ROS2 Learning week that we want to provide to the community. So this shouldn't affect. But in case that you have some ROSjects there that you don't want to use or whatever, you can try removing or deleting some of them, and it might fix the issue. However, I have already reached my colleagues, and we are already checking what's going on, so that even if you have reached the limit, you are going to be able to get the project. Okay. Gives us just some extra minutes to see if we can solve this issue. Okay, yeah, so they are telling me that it should be solved now. So for the people who was getting this storage limit error, can you try one more time to fork it, to click on this fork and open project? And you should be able to get it now. Could you try again and let us know here in the chat if it's working now for you? You can get the project. I think it was, let me see here. Schmallenberg was having this issue. K4K also was having this issue. So could you let us know if it has been solved now? If you can fork it without problems? Got it loaded? All right. Okay. K4K says that it is not working yet. Are you still getting the same error? Can you try refreshing the page, for instance, refreshing the conference page and clicking again on the button or something like this? Maybe you need to refresh the page to get the new configuration or... Same, still not working. We'll try loading process. Can you summarize again, please? Old Monk, so far we have not started yet, okay? So we are still getting everybody set up with the projects and so on. So I have not started yet. Basically, all you need to do so far, what we have done is to come here to the conference page and then go down, look for the conference documentation and click on the fork and open project. All right? I'm going to wait for confirmation of Schmallenberg and K4K that the issue has been solved in order to start with the class so that we are all set up and at the same point. All good now, says Roat. Okay. So were you having this storage limit error before? Due to the number of people in our system right now, you may need to wait a bit more than usual. Yeah, that's normal, Dan. That's normal. Since we are having lots of users right now in the system, it might take a bit longer than usual to load the project. So that's a normal message. Got it working now. Okay, great. So Schmallenberg got it working now. So it looks like it has been fixed and so let's see if K4K can confirm also that it got solved for him. But it looks like the issue has been solved. Okay, now the ROS2 Learning weekday is loading. Thanks. Okay, so K4K has also confirmed that it has been solved. Great. Okay, excellent. So yeah, we are ready to start now. So we have. Oops, I got. Okay, please, colleagues, take note of this because I have been here disconnected for no reason, which is quite strange. Okay, let me go back to my project. Loaded, it's loading. Okay, great. Okay, so we had a small issue here at the beginning, but no worries. We have been able to solve it, and we can keep going forward. All right. So yeah, once you load the project, as I was explaining, you should have this notebook automatically opened. Also, yeah. So this notebook is going to contain all the documentation for today, all the theory, the concepts, different examples, exercises, etc. Right? So basically the procedure is going to be similar as day 1 and day 2. We are going to be following here instructions and the pace of a notebook, but now we are in a project, which is a much more customizable or developer-oriented environment. All right? So yeah, you should have your notebook loaded here for the ROS Learning Week Day 3. And in this case, we are going to start with ROS2 basics already for Python. So this is going to be the first live class that we are going to do about, class that we are going to do about ROS2 Python in this week. And we are going to be building on the concepts that we have already learned on day 1 and day 2. All right. So on day 1, we learned about basic Linux commands. On day 2, we learned about basic Python programming. So we are going to be assuming this knowledge already. And we are going to focus today only in ROS2 basics for Python. All right. So I want to let you know that today's class is going to be something basic. And we have also just today, we have launched a new course in the Academy. All right, which is this one. No, it's not this one. Okay, so the links seem to be wrong. Let me look for it here in any case. Here we have it. All right, so we have launched today the ROS2 Basics for Python in 5 days course based on Foxy, all right, which is the full course on ROS2, where we are going to be covering everything from basic concepts to topics, services, actions, etc. All right, so this course has been launched today. Let me put it here in the chat right now. You can find it in the Academy. So just to let you know that today, we have published this new course on ROS2 Basics for Python. All right, so have a look if you want to check it out. And also, before starting, I want to remind all of you about the ROS Developers Day 2021, which is coming really close already. So it's going to be on June the 19th. All right, so very close already. And it's going to be a full day dedicated to ROS Developers, where we are going to be covering different subjects, very interesting subjects, which are going to be done by very well-known ROS developers. Most of them. You can have a look here at all the speakers' agenda, and you can already see what they are going to be doing in their speeches. So in case that you can find some subject that is interesting for you, so have a look. And so I have left the page here so that you can have a look and register. You are still on time to register. So yeah, I really encourage you to register and attend, because it's going to be super interesting. So don't miss it. All right. Of course, we are going to have also many speeches which are going to be based in ROS2. So also in ROS1, but we are going to have different speeches based in ROS2, as you are going to see here in the agenda of the conference. All right. So yeah, that's all for the introduction. And at this point, let's start with the class itself. So let me have a quick look at the chat here. The link is tagged at the bottom of the agenda. I don't get your comment. What? The link is tagged at the bottom of the agenda. I don't get it. It is a free course or preview course? No, this one is not. This ROS2 Basics for Python, it's not free. It's for subscribers. Okay, you can open it with a free account, and you are going to be able to preview it and see the first unit. But in order to access the full course, you need to be a subscriber. In this case, it's not a full free course like Linux and Python courses. All right. So first of all, what we are going to do is to set up our simulation, because of course we are going to be working with a simulator, with a gazebo simulation also today. All right. So the first thing that we are going to do is to start our simulation. Then for doing so, we are going to first of all open a shell. All right. So in this case, we can open a new web shell by clicking on this icon. All right. So here in the bottom bar, you are going to find the main options. You're going to find the web shells here where you can launch web shells, the IDE, Jupyter Notebook, also the gazebo. So basically, as you can see, the things are very similar to the course, but okay, I am getting these notifications, which this notification sound. Okay, thank you, Ruben. Okay, I get it now. All right. So basically, you have the same options like in the course, or the core of the system is the same, but here you can you can set it up as you prefer. All right. So for instance, in order to open a new shell, instead of having them there static in the page, here you can open a new shell like this by clicking on this first icon. All right. You can move it around as you want, how you prefer. Make it bigger, smaller. You can open extra shells if you want. You can also open extra shells by clicking on this plus icon here. All right, so as you can see, it gives much more flexibility. Yeah, so it's a better environment for developing. All right, so once we have opened our shell, so basically this is at the end, it's just a Linux shell like the ones we have been using in days 1 and 2. Where we can access all the workspaces, etc. So once we have started our shell, we are going to execute the following commands. All right. So here we have a series of commands which are going to allow us to start our simulation. So the first one is this source. We are going to source ROS2 Foxy. So we are going to source the ROS2 version that we are going to be working with today. So again, you can directly copy and paste the commands here from the notebook. Okay, same thing as we have been doing until today. So you can copy the commands directly from the notebook and pass them here. So I'm going to execute the first one, which is to source ROS2 Foxy. Next, I'm going to source this simulation workspace. Okay, so I'm sourcing this workspace because it's the one that contains the gazebo simulation packages. All right. So in order to be able to launch them, I need to source this simulation workspace. This simulation workspace, by the way, everything that I am doing here, we also have here, so the second icon, we have the code editor. Yeah, in this second icon here, first icon are the shells, second icon is the code editor. Basically, this is going to allow you to work in a graphical way. The same thing that we saw for the course, we can have it here. As you can see here, we have more workspaces, but don't worry about them. Basically, we are only going to be working with the ROS2 workspace. Okay? But as you can see, we have other workspaces here. Just don't worry about them. And just to let you know that inside this simulation workspace, the one that we are sourcing here in this second command, is where we have the gazebo packages. That's why we are sourcing this workspace and why we are executing this command, right? So that you know why we are doing this, right? But don't worry about it. Okay, let's keep going with the third command. So basically, we are going to go to a specific folder, which is this T3 Foxy, which is inside the simulation workspace. With a cd command, we are going to access here. And inside this specific path, we are going to run one of these sh scripts, one of these bash scripts. In this case, we are going to run this one, start simhouse.sh. All right? So I'm going to copy again the command from here, and I'm going to execute this script, start simhouse.sh, which basically is going to start the gazebo simulation. So let me run it. There we go. And as you can see here, things are happening. You are going to see some error messages in red. Don't worry, it's normal. Okay, don't panic if you see this. It's normal. It's not going to affect in anything. So now I have my simulation launched. However, in order to visualize it, I need to start and open the client. And in order to open the gazebo client, I need to click on this icon. Okay, this cube-like icon that you can see here in the notebook as well. You can click directly here on the cube icon, and this is going to open the simulation, the gazebo client, so that we are going to be able to visualize the simulation. And here I have it. Okay, so here we can see the simulation, which has opened here. This is the simulation that we are going to be working with today. All right? So let me summarize the steps I have done until now. So in the notebook here, in the how to launch the simulation section, you have everything explained, but basically you need to open a new shell, first of all. In this shell, you have to run these 4 commands that you have here in the notebook. And after launching these commands, you need to open the Gazebo client with this cube icon here in order to visualize the simulation. And at the end, you're going to see something like this, okay? Some walls here in the environment, and here at the center, the Turtlebot 3 robot. In this case, you can zoom in and you're going to see here the robot. All right? So far, so good. So have you been able to launch your simulations? Yes, no? Let me know here in the chat. Yes, yes. Okay. Yes. Any problem so far? Has somebody get lost in the way? No, I have problem. The process has died. This you mean? Juan? This process has died? What do you mean it has died? You have stopped it or something? There are errors. Yeah, it's normal. I also have errors here. Don't worry about the errors. Don't worry. It's normal. Don't worry about these error messages. That's normal. It's so cool that we can open Gazebo in this way. Yeah, yeah, right? It's interesting. And the nice thing here, in comparison with Academy, that's why it's more developers oriented, is that you can set up everything as you want. So I can put my shell here, I can put my Gazebo simulation here, my notebook, I can put it here, and I can configure everything as I want, right? So that I can have the environment as I prefer. Of course, by the way, you can also open things into new tabs, all right? In case you want to have something specific, for instance, I'm going to move this to a new tab now. The IDE, if you click in this icon here, open in a new browser tab, you can move things to a new tab, okay? In case you prefer to work like this, so you can basically customize the environment as you want, all right? The icon is not doing the client. Is there a command line way to launch the client? No. You have to open it like this with this cube-like icon. Yeah, GCP ROS. This error is normal. This error that you are pasting here in the chat, insert model widget, whatever, it's normal. I also have it here. See, I also have these errors. This is some model-related errors, but are not important right now. So don't worry. No, but appears the process has died. Okay, then try launch it again, Juan. Launch everything again. Oh, it looks like you have stopped then this process. You have pressed Control C or something here in the shell because you had sent a kill signal to the process. but gazebo not open. No, you have to open the client by clicking here in this icon here. So one thing is the shell. Here we have started the gazebo program, let's say, but in order to visualize the simulation, you have to click on this cube-like icon. You have to click here on this icon, and then this is going to open the client. Okay. I see that message too. I had to click. Yeah. Okay, so TSEDL is suggesting here some things to GCP ROS. So yeah, one thing is the shell here where we are now executing these commands. Okay, we execute these commands in order to start the specific programs of Gazebo, and we run these commands in the web shell. Okay, but once we have run these commands in the web shell, we need to open the client by clicking on this icon here. Yeah, then this is going to open this new window where we are going to be able to visualize the simulation. Is there a way to reopen the documentation? I went to the basics in 5 days course and then tried to go back to the day 3 project and it's now empty. If I click fork again, it just goes to the empty project. Okay. Try removing it and copying it again. Done. You can come here in the main page. You can come here to the My Projects section in the left menu. My Projects section. Okay, and you can come here to the project. You are going to find it here in your workspace, and you can remove it. Okay, so try removing it and copying it again. Let's see if that helps. Okay, so for the rest of the people, let me know here in the chat. Is everybody ready with the simulation and everything loaded? Okay, so Juan is ready now. Great. Juan, who was having problems, is ready. Great. Arasu, Mirna, Alves, Seni. Okay, great. So I see that most of you are already set up and ready. So let's go for it then. Okay, also GCP, which was having issues. Great. Okay, then let's go for it. So let me make this. In fact, what I'm going to do is to move I'm going to move. Well, no, not for now. I'm just going to maximize it or make it here a bit bigger. All right. So what is ROS2? Okay, so this is basically the main question. What is ROS2? So we can understand ROS2 as an ecosystem, all right, or something like an ecosystem where we can make communication with robots easier, all right? So basically, ROS is like an ecosystem which provides some tools, utilities, programs, etc., which are going to allow us to communicate with robots in an easy way, all right? However, we are going to see now during today's class and during this notebook, we are going to see some points that are going to help us to better understand what ROS2 is. Okay, ROS2 or ROS, in this case ROS2. So the first thing that we are going to do is to move a robot with ROS2. Okay, so we are going to start with practice, as we like to do always, and we are going to start with this example. So what I suggest that you do at this point is to minimize this shell, the one that where the simulation is running. Okay, so let's minimize this shell, because maybe by mistake you are going to close it or something, and this is going to affect the simulation. So let's just forget about this web shell where we have the simulation running, minimize it, and we are going to open a new one, okay, where we are going to start working. All right, a brand new shell. So in this new shell, I'm going to start running more commands. So first of all, I'm going to source ROS2 Foxy. Why? Well, because I'm going to be executing ROS2 commands. So I have to source the specific ROS2 version, which in this case is ROS2 Foxy. All right, next I'm going to source again the simulation workspace, which I know it contains the gazebo related packages and the robot related packages. And finally, I'm going to run this command here, ROS2 run turtlebot3 teleop keyboard. Okay, so I'm going to copy the wall command and I'm going to run it here. Okay, so what have I just done? Well, what I have done is I have just launched a teleop keyboard program, which basically is a program, a ROS2 program, which is going to allow me to control and move the turtlebot3 robot, the robot I have here, using the keyboard. All right, so let me set up this in a way where we can see everything better. Let me get a bit closer to the robot here. There we go. Okay, so now as you can see here, as it is indicated in the shell itself, using these keys and the keyboard, I can move the robot. All right, so for this, you need to, guys, have the focus on this shell, okay? So you need to make sure that you have the focus on this shell here, all right? So for instance, let me try right now. I'm going to start clicking here some keys on my keyboard to move it forward, for instance. And as you can see, the robot starts here moving forward. I can also make it turn, of course. Let me turn it to the left now. There we go. Now to the right. To the right, there we go. Okay, so basically this program is going to allow you to control the robot with the keyboard. Okay, play a little bit with it if you want, in order to get familiar with it. And yeah, so finally I can stop it also with the key S of the keyboard. With the key S, I'm able to stop it. Okay, there we go. So what have I done just now? What we have done just now is to launch our first ROS2 program, okay? And for doing so, we have used, in this case, the ROS2 run command, okay? How does this command work? Well, we are going to always have to use ROS2 run, and then we are going to specify the package name, which in this case, let me stop this program already so that I can show better. Okay, so ROS2 run, then the name of the package, which in this case is turtlebot3 teleop, and the name of the executable, yeah, of the program, let's say the executable that is going to start the program, which is teleop keyboard in this case. Okay, so this is one of the ways in which we can start programs in ROS2, which is using these ROS2 run commands. Another option, as you can see here, is to launch programs by using a launch file. Okay, we are going to see both today, don't worry. And the structure used in order to launch a program using a launch file is the following one. Okay, instead of ROS2 run, it's going to be ROS2 launch. And then we are going to specify also the package name first, and second, instead of the executable file, we are going to specify the launch file. Okay, so get familiar for now. Just get familiar with these structures. Okay, ROS2 run, ROS2 launch are going to allow you to start programs in ROS2. Okay. Then we have started mentioning here package, executable, launch files. So let's start by the beginning. So what is a package? Does somebody know what a package is, or what we use packages for? In ROS2 or in ROS, it's the same case. So basically, we are going to use packages in order to organize our code. Okay, so whenever we start working or developing something, we are going to create a package at the beginning, and inside that package we are going to put all the code. Okay, so this way is going to allow us to organize our code. For instance, we can create a package which is going to control the movement of the robot. We can create another package where we are going to put all the programs related to the camera sensors of the robot. We can put create another package where we are going to put all the programs related to the security of the robot, etc. Okay, so this way, this structure, which in fact we can see here in the IDE inside the simulation workspace, we can see that we have many different packages. Okay, and inside every folder here we have more packages. All right, so see, we have many packages. For instance, here we have one package which it contains examples for the Troubleshooting robot. We have another package which is related to the navigation. We have another package which is related to the teleoperation, the one that we have just used, this one. All right, so basically, putting our code in packages, as you can see here, and structuring it in packages is going to allow us to better organize our code and not have all the programs here without any order. All right, so basically this is the main reason that we are going to create packages. All right, so actually, let me recover this. There we go. Okay, so in ROS2, when we create a package, we can create a package in two ways, let's say. Okay, one is that we can create a C++ based package, and we can also create a Python based package. Okay, so when we create a package in ROS2, we are going to decide which kind of package we want to build. Is it going to be a C++ related package? Is it going to contain C++ programs, etc.? Or is it going to be a Python package? It's going to contain Python scripts and so on, right? In this case, of course, we are going to work on Python, so we are going to focus on the Python way, all right? So in our academy, by the way, as in the same way that we have the ROS2 Basics course for Python, we also have the ROS2 Basics course for C++, okay? Where we explain the counterpart of ROS2 Basics using C++. In case you are a C++ programmer, okay, just to let you know that we have the two courses. One is based in C++ and one is based in Python. However, today and in this week, we are going to focus on Python. So let's go with the Python way. So basically, when we create a package based in Python, a Python package, it's going to contain the following things. So it's going to contain always a package XML file. Yeah, so when we create a package, all this is going to be auto-generated. Yeah, you are going to see it in a moment. So the basic structure of any Python package is going to contain the following: a package XML file, which contains meta information about the package, like package name, versions, maintainer, dependencies, etc. Is going to have a Setup.py file, which is going to contain instructions about how to compile and install the package. It's going to contain a setup.cfg file, which is something that is required when a package has executables so that ROS2 run can find them. And finally, it's going to contain a folder which is going to have the same name of the package. All right, we will see all this in a moment, okay? So don't worry. In this directory, which is going to have the same name of your package, is where we are going to put, for instance, the Python scripts that we create, okay? So all these files and folders are essential, okay? Every Python package that you create is going to contain this structure, okay? Then it can have extra things, but these are the essential parts, all right? So, okay, so this is super good, but let's create a package, okay? So, Alberto, stop talking and explaining me things, and let's go to the practice. Okay, so let's create a package right now. Let's go for it. So, first thing I'm going to do, again, source the ROS version that I'm going to be working with, which in this case is Foxy, okay? If you don't have sourced your web shell, source it, okay? If you have already run this command, you don't need to run it another time, okay? There we go. Now, we are going to move to the ROS2 workspace, okay? So as you can see here in this project, in this environment that we are working with, we have many workspaces which are meant to be used for different reasons. In this case, let's just focus on the ROS2 workspace. So let me copy and paste, not this one, sorry. So we are going to go to the ROS2 workspace. Let me do it right now. ROS2 workspace. And I'm going to find different folders here, okay? In this case, in the same way as it happens in ROS1, so if you have some experience in ROS1, you already know this. So whenever we create a new package in ROS2, we are going to put it in the src folder. All right? So we are going to need to go inside the src folder. Yeah? So right now we are in the ROS2 workspace src folder. So every time that we want to create a new ROS2 package, we are going to come to the src folder of the workspace, and we are going to put our package here in this folder, okay? Not in the log folder, not in the install folder, not in the build folder. We are going to create it and place it in the src folder. All right? Okay, so once I am here, once I am in the src folder, I can run the command in order to create a package, which is this one, okay? We are going to explain now the structure. Right now, I'm going to copy it directly from the notebook and paste it here. And run it, of course, okay? This is going to generate certain logs, as we can see here. And if I run an ls command, I'm going to see a new package has been created here, okay? I'm going to be able also to visualize it through the IDE, through the code editor. If I open the ROS2 workspace and I go to the src folder, I'm going to see my package has been created right here, okay? And I can see some things that I have just commented, okay? Remember here that we were commenting basic structure. So we can see here that it has been automatically created this package XML file that we mentioned it a moment ago, yeah? Also the Setup.py file, we can see it here, automatically created, and the Setup.cfg file also. We have them here, okay? And also I can see this folder which has the same name of my package here. I can see it here, okay? So I can see that the basic structure of the Python package has been automatically generated with this command. All right? So now let's try to analyze and understand a little bit more what this command does. What is the structure of this command? Okay, it's pretty simple. Let me put the command here again. So basically we are going to use this structure always to create a package, all right? ROS2 package create, ROS2 pkg create, okay? These are the key commands in order to create a package. Then we are going to specify an argument which is the build type, okay? And in this argument, we are going to indicate, we are going to specify which type of package this is going to be. In this case, we are specifying amend Python. What does this mean? This means that this package that I am creating with this command is going to be a Python package, okay? For instance, if I wanted to create a C++ package, I would change this for amend CMake, okay? If I specify amend CMake, I'm going to create a C++ package. If I specify amend Python, I'm going to create a Python package, all right? Then next thing that I am specifying in the command is the name of the package, okay? In this case, I am naming it my package. You can put whatever you want here, okay? You can name your package as you want, all right? However, there is always I don't know how to say it now, a recommended way of naming packages, okay, which is to try to avoid to use capital letters, for instance, and use underscores, all right, like this. You can check extra information of that. And finally, as you can see, we are specifying the dependencies argument, okay? In the dependencies, we are going to specify which other ROS2 packages am I going to need in my package, okay? In this case, we are specifying RCL.py, all right? Later in this class, we are going to talk a little bit more about this, but for now, just keep in mind that whenever you want to create programs in Python for ROS2, you are going to need to add this dependency, RCL.py, okay? And just so that you know, in case you want to develop programs in C++, then you would use RCL CPP, okay? In our case, we are going to be working in Python, so we need to import RCL.py, which is the Python client library, okay? Yeah, so far so good. Makes sense, okay. I can see that some, yeah, best practice. This is what I was trying to say a moment ago. Okay, so I can see here Ricardo is answering some of the questions. Great. All right, so far so good. Are you following? Let me know, give me some feedback here in the chat. Yeah, no. All good. Okay, great. Yes, keep going on. Okay, perfect. Very clear. Okay, great. So let's keep moving. Then we have created our first ROS2 package, okay, which we have named my package. Then there are some commands that we can use here in order to see if the package has been created properly. For instance, ROS2 package list command, as it's a command which is pretty self-explanatory, right? So basically this command, what do you think it's going to do? Yeah, it's basically it's going to list all the packages of the system, yeah? So if I run this command, I'm going to get, as you can see, all the packages that the ROS2 system is detecting, right? As you can see, there are many of them, all right? Then we can filter this command, for instance, with the grep tool, we can filter this command for a specific name, okay? So for instance, I can filter and get only the packages which have the Turtlebot 3 keyword, okay? Then I'm going to only see the packages which have the Turtlebot 3 keyword, yeah? So that are related to the Turtlebot 3. Or, for instance, I can filter and try to look for my package, the one that I have just created. Oh, and it's not appearing. Why it's not operating? Can somebody tell me why the package that I have just created, which is here, I can see it, it's here. Why it's not appearing when I am when I'm trying to list it here? Can somebody tell me why? Did I do something wrong? Am I missing any step? I don't have any Turtlebot packages? What do you mean, hello? Probably you have misspelled something here, because if you have the simulation running, you have these packages for sure. Not compiled, that's it. That's it. For Python scripts, Cockamil does the search path magic. You should source it, you have to compile it. Okay, very well, very well. Yeah. You are right, guys. So, in order to make my ROS2 system detect my new package, I need to first compile it, as you are saying, and I need to source the workspace after compiling. Okay, so that the system knows that, hey, there is a new package here. Okay, then let's see how to compile in ROS2. Okay, so in ROS2, the command used to compile is colcon build. We are using the colcon tool. Okay, in ROS1, if you have worked with ROS1, we were using catkin or catkin build, catkin make, etc. So in ROS2, we are using colcon. Okay. So whenever we want to compile our packages, our workspace, we have to use the colcon build command, all right? Then where do I compile? I compile here in the src folder? No, not in the src folder, okay? In the src folder, I'm going to place the packages. But for compiling, I'm going to go to the root of the workspace. In this case, it's the ROS2 workspace folder, okay? This is the root of my workspace, ROS2 workspace. So here, in the root, is where I'm going to run the colcon build command, okay? And basically this, what it's going to do, is to search which packages I have in the src folder on my workspace, and I'm going to compile them all. In this case, I only have one, which is my package, so I'm only going to compile this one. So let me run this command. Then compilation is going to start, and it has finished, okay? So now I have compiled, and now what do I need to do? I need to source my workspace, okay? So for this, I'm going to run the following command. Source install setup.bash, okay? So I'm going to source this setup.bash file. Then with this, what I'm going to do is to make sure that my workspace gets all the latest changes that have been done into the packages, okay? So now, if I go back and I run the command again, ROS2 package list, and I look for my package, now the system, as you can see, is able to detect it, okay? That's why you can see the package, my package, Kevin, because you need to compile and source the workspace. All right? Then you might say, hey, Alberto, but what if now I only have one package, but what if inside my src folder, instead of one package, I have 100 packages? What if I have only modified one and I don't want to compile 100 packages, but only one package? Okay, no worries. Then we can use the packages select option, okay? We can use colcon build, packages select, okay? And only specify the packages that we want to compile, okay? And it's not colcon, it's colcon build, okay? Colcon build, packages select, and then we can specify all the packages, the specific packages that we want to compile, instead of compiling the whole workspace, okay? It's exactly the same. Okay, so I am compiling only my package here, all right? There we go. Okay, so we have learned what a package is, how to create a package, how to compile a package, But there are still some things that we have not talked about related to the first exercise that we did, which is launch files. Okay, so we know that we can start programs, as we have done already, with the ROS2 run command. Okay, but at the beginning of this class, we told that we can also launch programs using the ROS2 launch command. Yeah, you remember we talked about this earlier. Then in order to use the ROS2 launch command, we need to create a launch file. All right. So what are launch files then? Launch files basically are files that are going to allow us to launch multiple executables at the same time. Okay? So we can combine and launch different executables, etc. We can do many other things because launch files in ROS2 are actually Python scripts. All right? So this is something different from ROS1 also, so an important difference. In ROS1, launch files were created using XML code. Yeah? In ROS2, launch files are Python scripts. Okay, so an important difference between ROS1 and ROS2 that you need to know. Okay, so because launch files are Python scripts, they provide a lot of flexibility. All right. However, don't worry about this now. We are going to keep it simple for now. Then we can check an example, which is this launch file, the launch file to launch the keyboard, the teleop keyboard. Okay. So actually, let me. I don't see any package. If I grep turtle, only have turtle sim. I think that's enough to run the demo. Thank you. If you are not seeing these packages, where do I have them? If you are not seeing these Starter.py packages, it's because you have not sourced the simulation workspace, okay? You have not sourced the simulation workspace, okay? That's why you are not able to see the Starter.py packages. If you source the simulation workspace, you are going to be able to see the Starter.py packages, okay? All right, so we can, for instance, come to the IDE right now, to the simulation workspace, come to the Turtlebot3 folder, Turtlebot3 teleop. No, not here. Okay, so where it is? Let me minimize this. Okay, so where do I have this? Let me check here. I'm using the command. But you've also seen that how do they operate? Let's take a look at an example. If you want to use a launch file to start the teleop keyboard executable, you need to write something. Okay, so it doesn't exist yet. Okay, so in the same way that we have started the teleop keyboard program, here in the first demo with this command, running the teleop keyboard executable, we can create a launch file that is going to start also this executable. So what would the structure of this launch file look like? It would be something like this, okay? So at this point, have a look at this Python code and try to analyze it and see the different parts, okay? I'm going to do a short pause of a couple of minutes and I'll come back, okay? So far, keep reading, have a look at this code, try to analyze it, what things we are importing. Here we have a function, a return. We have some parameters here. Have a look, okay? Have a look and get familiar with this. All right, I'm going to come back in 2 minutes only. All right, I'm back. What happened? I repeated the steps. No package when I grep Turtlebot 3. Well, what you have to do, see, I'm going to open a new shell from zero, okay? So if you source opt ROS foxy setup.bash, now probably we are not going to see. Let me check only for grep Turtlebot 3. We don't have, okay? So now I'm going to source simulation workspace install setup.bash. I'm going to repeat the package, and now I get them, okay? So you need to do this source in order to be able to see the Turtlebot 3 packages, okay? Why? Why you need to do this source? Because these packages are inside this workspace. All these packages are inside the simulation workspace, right? They are inside this simulation workspace. Here I have all the Turtlebot 3 packages. That's why if I don't source this workspace, I'm not going to be able to see these packages. Exactly the same that happened with my package. I need to source the ROS2 workspace in this case in order to be able to visualize my package. All right, so yeah, we were analyzing this launch file. So as you may have already seen, it's pretty simple, all right? So I am first of all doing some imports that I'm going to need. I'm importing here, do you remember the imports that we discussed yesterday? Yesterday we were importing this robot control class, etc. So basically here we are doing the same, all right? We are importing other elements that we are going to need in this case. Then I am defining one function, which is this function called generate launch description, okay? And inside here I'm returning an element which is launch description, okay? Then inside this launch description I am returning here a node, a ROS2 node with three elements: a package, the name of the package, the name of the executable that I want to launch, all right, which as you can see are the same ones that I was using here in the ROS2 run command. Name of the package and name of the executable, all right? And finally, I am defining a third argument here, which is this output, and I am setting it to screen. Basically, this is going to set the output of this launch file. The output generated, the logs generated are going to be printed into the screen, into the web shell screen. So I'm going to be able to see them here in the web shell, all right? Other options, for instance, is to redirect the output to a log file, for instance, okay? So, yeah, okay, here we have all the explanation, but basically the most important parts are these. So basically keep in mind this structure, you are going to use this kind of function always, okay? And then here you are going to specify the package name, the executable that you want to start with this launch file, and where you want to put the output. Usually you are going to select the screen, okay? All right. So now that we have more or less all this information, I think that it's time that we create our first ROS2 program. What do you think? Let's go for it, right? So let's create our first ROS2 program. Okay, this has muted. Let me mute this back again. All right, so where do I place my Python script? So in order to create my first ROS2 program, I'm going to create a Python script, right? In this case, it's going to be simple.py. So where in my package, let me minimize this again, where inside my package I'm going to put my Python script? Can somebody tell me here in the chat? Do I put it here? with these other files, the package, the setups, inside the test, inside the resource, inside the my package. Where do I put it? Does somebody know? My package. Okay, that's right. Right answer. Hello, Seni. So, whenever I create a new script, I'm going to put it inside this my package folder, the one that contains the init.py. Okay? The folder which contains this init.py, this is where I'm going to place my Python scripts. So, what I'm going to do is to just create a new file, and I'm going to name it simple.py. Okay? This is going to generate, as you already know, an empty file here. Okay? Then inside this file, I'm going to copy and paste the code that I have here in the function, in the notebook, sorry. Okay? So I'm going to select this whole code, copy it, and paste it with Control V. Okay? It's not going to allow you to paste it like this. Okay? It's going to give you an error, so you're going to need to paste it using Control V. All right, there we go. So here I have my code. Okay, so let's keep advancing, and later we are going to review this code and what it means. Okay, then I have my code. Next thing that I'm going to do is to create my launch file, right? So where am I going to put the launch file? Well, in order to have my package better organized, what I'm going to do is to create a new folder. Okay, so inside my package, I'm going to create a new folder, which I'm going to name launch. Then inside this launch folder, I'm going to put the launch file that I create. Okay. In this case, I'm going to create, here in the notebook, it's doing it from the web shell. Okay? You can do it from the web shell if you want. In this case, I prefer to do it here in a graphical way using the code editor, all right? You can do it as you prefer. So we are going to create a launch file, which is going to be named like this, okay? I'm going to take the name from here so that I don't have to write it. Then I'm going to create here, inside the launch folder, a new file, and I'm going to paste the name here. It's not this one. I didn't copy it properly. My package launch file. Okay, copy, new file, paste. There we go. Okay, and here I have my new file, my package launch file. Then in the launch file, as you can see, it has the extension .py because it's also a Python script. Okay, so the launch file is also a Python script. Then inside the launch file, what I'm going to do is to paste this code here. Okay, the code that I have here in the solution of exercise 1.1. So I'm going to copy this code and paste it into my launch file. Okay, again, I have not copied it properly. Copy and paste. Okay, there we go. All right. So let's, okay, at this point, let's try to analyze everything. Well, no, let's keep moving. Let's keep advancing, and we will review everything later. So once we have created the Python script and the launch file, the next thing that we need to do is to modify the Setup.py file. Why? Because we need to generate an executable from our Python script, right? So in order to run a ROS2 program, as we saw before, we need to generate an executable file, right? We need to generate an executable. So in order to generate an executable from our Python script, we need to use the setup.py file, and we need to update it, okay? in this case, we are going to define and generate the executable here in the console scripts, okay? So in this case, in our setup, in the setup.py file that we have, that it has been automatically generated, you can open it here and have a look. This, by default, it already contains some things. But if we create a new program and we want to create a new executable, we are going to need to add it here in the entry points inside the console scripts, okay? So here we are going to need to define any new executable that we want to generate, right? In this case, you can get the code directly here from the notebook as well. I'm going to do it. So I'm going to copy this line and paste it here, okay? So what I am doing here in this line, what I am doing is that I am generating a new executable which is going to be named simple. Yeah? So I'm generating a new executable which is going to be named simple. And this executable simple, named simple, is going to be generated from the main function, of the simple.py script, which is inside the folder my package. Okay? So inside the folder my package, I have a script which is named simple, which is this one, and inside this simple script I have a function named main, as you can see. Then from this function, we are going to generate an executable named simple, okay? Then this executable is the one that we are going to run in our launch file, yeah? So from the my package, we are going to execute here the executable named simple, which is the one that we are generating here in our setup.py file. All right? But what else? We need to add one extra thing. In this case, we need to also generate the launch file, okay? And this, we are going to do it here in the data files. As you can see in the notebook here, also, we have an extra line that you can copy directly here from the notebook, okay? So let me do it. Let me copy it here. It's this line, the last line here inside the data files parameter. I'm going to copy, this. Okay, why I cannot copy it. Let me copy it with Control C then, Control C, and add it here. There we go. Okay, so basically what we are doing here is that we are installing, let's say, we are installing all the launch files that we have inside the launch folder. Yeah, so I'm searching for the launch folder, and every file that has the .launch.py extension, we are going to install it into the share space of my workspace, which is inside here, okay? Something related to the installation. But this needs to be done in order to be able to use these launch files, okay? Then there is one final thing that we need to do, because here we are using the OS function, as you can see. Then we need to import also this, we need to import two extra things. We need to import OS and we need to import glob, okay? So I'm going to copy these two imports from the notebook and add them as well here. All right, there we go. So now we have our setup file ready so that it's going to install all the launch file that we have created. It's going to install it, and it's going to generate this simple executable from my Python script. Okay, so we are ready. Then at this point, we are ready to compile already. Okay, so that's what I'm going to do right now. I'm going to come here to my shell. I'm going to go inside the ROS2 workspace, to the root of the workspace, and I'm going to compile using call build. All right, so there I have compiled my package. I need to source. Okay, don't forget to source. There we go. And finally, I can run the program. Okay, so at this point, I have already generated the executable. So I could run directly the executable if I want with ROS2 run, right? So I can use the command ROS2 run, put the name of the package, and put the name of the executable, which is simple. So I can run my program like this. Let me execute it like this. And basically I can see here some things being printed. See? Moeyo, Byakugan, Korega, okay? But also, since I have generated the launch file, I can use the ROS2 launch command. So that it would be ROS2 launch, the name of the package, which contains the launch file, and the name of the launch file, which in this case is my package launch file. Okay, my package launch file.launch.py. Okay, and basically this is going to run also the executable, as you can see. Okay, it has some extra information related to the launch, but at the end I can see that it's the same output. Yeah, I have the same sentence being printed. All right. So now, what I am actually running? So what is this simple.py program doing? Super simple. Okay, so it's a super simple program. I am importing RCL.py, so I am importing the Python client library. This is something that I'm always going to have to do. Okay, when I create a Python program for ROS2, I'm going to have to import this RCL.py always. Okay, always. And also, I'm going to need to import the node class. All right? This is going to allow me to generate new ROS2 nodes. We are going to see in a moment what are these nodes. Okay? But basically, these two lines we are going to need to import them always. Then, in this case, we are creating a main function with no arguments. Here, basically, what we are doing is to initiate a node, a ROS2 node. Then we are running a print command where we are printing this sentence, okay, which is the sentence that we are seeing here and here. So basically, the only thing that we are doing here is that we are printing this string, and then finally we are shutting down our node. Okay, so super simple. This is basically our simple.py script. Yes, super simple. The presentation is not working. I can see or hear anything. Hello? Can you hear me? Guys, hello? It's clear for me. Can you hear me? For me, it looks like everything is working. Yes. I see and hear fine. I can hear you. Okay, so Seni, probably it's some issue with your connection. Okay? So try to make sure that your connection is working. Try refreshing the browser or something because the stream should be working properly. Okay, thank you guys for the feedback. Okay. So far, so good. So we have just created our first ROS2 program, okay? In fact, we have done a lot already. So, let me make this bigger. Actually, I cannot see the stream now, neither here. I cannot see the stream here neither. Why I'm not seeing the stream? I don't understand. Why I cannot see it? That's super strange. So you can see the stream here, in this page here. You are seeing it? Why I'm not seeing it? It doesn't make sense at all. Let me try to make some quick verifications. Okay, let me make some quick verifications. Just 1 second. Okay, I'm going to try to refresh this and see. Oh yeah, I'm not seeing it. Okay, this makes, sorry guys, but this makes no sense for me, and it's super weird that I cannot see myself here. I don't understand. What's going on? Moving to a new tab, you say? Okay, so I actually don't know what's going on. Okay, in any case, I'm going to keep going, even though I am not seeing myself. I can see the chat at least, so I will keep going. Just confirm. I'm going to minimize this then. Confirm here in the chat that you can see what I am doing here. So you can see everything that I am doing here, all the commands that I execute and everything. You can see what I am doing and the notebook and everything. That's what is important. The most important thing is that you can see what I am doing. So I don't mind if I cannot see myself. So can you see all this that I am doing here, moving the notebook, everything? Yes, yes. I see your screen, no problem. Works. Okay, great. Then I'm going to keep going. Okay, then let's keep moving. All right, so let me make this bigger. Okay, so we have just created our first ROS2 program. But not only program, we have created our first ROS2 package from scratch, which contains our first ROS2 program, which is this one, and a launch file, okay? So we have created our first ROS2 package. Then, let's keep advancing. Let's keep moving on. We are almost there. So yeah, as we were explaining, the setup.py is super important, okay? It's going to allow us to generate new executables in the entry points. It's going to allow us to install launch files, etc., okay? So have a look if you want by your own here to better understand basically the key point of this file. I'm going to keep moving, and I'm going to introduce ROS nodes. Yeah. So here we were talking about nodes. We are generating some nodes, right? Here I was saying that we are generating one node. Also here we are importing the node. Okay, so actually, what is our ROS2? What are nodes? So let's actually see what are nodes. So basically, nodes are, let's say that a node is going to be responsible of one program, okay? Of one process, let's say. So each node should be responsible for a single module. So one node for controlling wheel motors, one node for controlling a laser rangefinder, etc. Yeah, so basically each node is going to control one ROS2 process, okay? However, in ROS2 there is something called node composition, which allows to run multiple nodes in a single process, okay? However, right now this is too much, so let's just think of nodes as units, like we can see in this graphic here, so that each node can communicate with other nodes through topics, services, etc. Yeah. So basically, let's say that we are going to have one ROS2 program here, which is going to be contained in one node. We are going to have another ROS2 program here, which is going to be contained in another node, and another ROS2 program here, which is going to be contained in another node. And each node and each program is going to be able to communicate between them using some things that are called topics. Okay? However, we are going to talk about topics tomorrow. So I'm going to skip this for now. Just get this idea, have a look at this graph here and try to understand it. Okay? In any case, we can analyze the nodes that are running in the system using the ROS2 node list. Right? So, what if we run this command right now here? ROS2 node list. Okay, I'm getting an error. What is happening here? Can somebody tell me why I'm getting this error? Can somebody tell me in the chat why I'm getting... Okay, I can see the stream now. Yay! I have recovered my... Okay, great. Actually, maybe I'm going to open it here again. Yeah, so I have recovered it also here. Great. All right. So let's put everything back to normal. So can somebody tell me why I'm getting this error? Source shell file. Okay, it has to do with source, yes. I need to source ROS. That's right, TSEDL has the solution. I need to source opt ROS foxy setup.bash. Otherwise, I'm not going to be able to use ROS2 commands, right? So let me repeat now, ROS2 node list. Okay, so I can see here some nodes. So I have one node here related to the camera, another which is related to gazebo, another node here which it's called moving service, another node here for the EMU, for the laser scan, for the differential drive. I can see different nodes, okay? So I can see that there are some nodes running. However, our program actually it's not showing any node at this point. So what we are going to do right now is that we are going to modify our program so that it generates a node. Okay? So we are going to copy this code that we have here in example 1.7. We are going to generate this code here, copy it and paste it here to the IDE, substituting the old one, which is this one. There we go. And we are going to run this new code. So what do I have to do? Can I run it directly here? Can I run it now? ROS2 launch my package. Can I run it directly, or do I need to do something before? I have to compile, right? So I have updated my simple.py script. I have updated my program. So if at this point I run the executable, simple.py, this executable, simple executable, is going to contain the old code. So in order to update my executable with the new code that I have just added here to a simple.py script, I need to compile. See? So let's compile. When I run it immediately, it was the previous version. That's it, exactly. So we need to compile again, source the workspace, and now we can run the command. ROS2 run, launch, and it was something like my something like this, right? Or not? My package launch file, yeah. Oh, yeah, I have wrong my command. ROS2 launch my package and my something. It should autocomplete here with the tabulation key. There we go. Okay, so let me, oops. Okay, there we go. Now, let me run it. Okay, so now I can see that it's generating a loop. Can you see? So it's generating a loop. Actually, what we can see here is that we are generating a class, a new class here, named myNode. Then inside this, we are defining a new node which is going to be called Byakugan. Okay? And then I am creating a timer which is going to be triggered every 0.2 seconds. So every 0.2 seconds, this timer callback function is going to be called. And in this timer callback function, basically I am printing also this sentence using loggers in this case. Okay? Here I'm using loggers. Then in my main function, I am initiating the Byakugan node, as you can see, and I am calling the spin function. This spin function is going to pause the program execution. It's going to be paused here, but not paused because, so the main thread is going to be paused here, but this timer callback function is being called every 0.2 seconds. That's why I am seeing all this here, okay? So now, since the program is running, is spinning, I can open a new shell, source opt ROS Foxy, and I can run the ROS2 node list command, and I'm going to be able to visualize my node, Byakugan node. Yeah? So here you can, okay? Yeah. Here you can see the client libraries that I already introduced before. RCLPy is the Python client library. That's why we are always adding this as dependency when creating Python packages. And RCLCPP is the C++ client library. Yeah. We also have the environment variables, and that's it. So basically, I'm going to finish it here so that you can have a last look here to the these last sections, okay? And I'm going to finish it here because I'm already past the time. All right, so any final question that you want to make here before we finish the class? Yeah, so far so good. Okay, I cannot see any questions. I don't know if it's because you don't have questions or because the chat is bugged. So let me come here and see the chat here. All good. To compile it when I run it. Yeah, so okay, here I get them. ROS2 launch my package was not found in the shared directory of package my package, which is at the this problem, Kasim, this problem that you are pasting here, this problem is because you have not added to your setup.py in this exercise here. Yeah, when we were editing here the setup.py file, you have not added this line to your setup.py file, okay? You have not added this line. That's why you are getting this error. You have to add this line to your setup.py, okay? You need to add this line. Also, of course, you need to add this one to generate the executable. And because you have added this line, you need to add these two imports also, okay? So have a look here at the notebook and compare it with yours. You are going to see that you have this line missing. Yeah, it's because of this, Kasim. Have a look. Have a look at this setup.py file. You are going to see that your file is different. You need to add this line in order to install the launch files in the shared directory, which is actually what it's complaining. He is saying that your launch file was not found in the shared directory. See the error message? It's saying that this file was not found in the shared directory of the package. This is exactly what we are doing here. We are adding the launch file to the shared directory. So verify this line, okay? I could not understand how the code worked. Which one? This one? This is, we only have this callback function which is being executed every 0.2 seconds, okay? We are using this create timer function, which every 0.2 seconds is going to call this function, timer callback, which is defined down here. And in this function, we are basically printing this string, okay? But instead of printing, using print, we are using the getLogger function, which actually is a function of ROS, which is used to generate logs. Yeah, this getLogger function is more professional. It's going to print the messages like this. See, let me stop the program right now. By the way, see, it generates the logs in this way, with the log level, the timestamp, the node, the etc. The process, sorry, etc. Yeah. And here what we are doing is to just generate this node. We are calling this class in the main function. We are calling this class. We are initiating this class. And then we are using the spin function. The spin function basically is going to stop the program. It's going to pause the program here. See, it's going to pause the program here so that it doesn't stop. It's going to keep here running, and it's going to keep running. In this case, it's going to keep executing every 0.2 seconds the timer callback function. Yes, launch folder should be in the my package folder. Inside the my package folder, we have this launch folder here, launch folder. And inside the launch folder, we have the launch file. This is the structure. Okay? All right, so I'm going to end it up here. So yeah, thank you very much for being one more day with me. We have already completed day 3 of the ROS2 Learning Week. And tomorrow we are going to go for topics, ROS2 topics, okay? So be prepared, because tomorrow is going to be a good day. We are going to start creating more complex programs, so be prepared for tomorrow. And until then, take care as always and keep pushing your learning, all right? So you can keep working here with the ROSject, doing tests, whatever you want. And for any doubt that you have, you can post your questions in the forum, all right? As always. So yeah, thank you very much for this class, and I will see you tomorrow. Bye bye.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises. A fast and easy way to empower your team with ROS.
From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects.
Want to become a happy Alberto? Request a demo today.